Lake in blue.
Perfect. Okay, so I'll begin. Sorry for the delay. I had some networking and hardware issues, but now everything should be good. So I want to just begin very quickly. I'm going to motivate a little bit behind what's Azure Data Lake, how to think about it, and the pieces. And there are several pieces, but one of the stories I wanted to make sure I get across is how we got into this, the newest parts of the Azure Data Lake. Now, Microsoft is not new to big data. We've been working on an internal big data system since 2008, and this is something that has really, we've integrated into all of Microsoft, not just Bing, but one of the first things it did is help Bing increase its search share, and that was through experimentation. That means like A/B testing, machine learning, classification on user and operational behavior for Bing, a huge impact for us in the company. And as we saw the success of that and the Bing division grow, other teams wanted to take advantage of it. And interestingly, as our data started growing, and now we're in multiple exabytes of data, we hit some interesting challenges, and the challenges really aren't about scale of numbers. It's about the scale of people and the scale of data. And what I mean by that is, we have over 10,000 developers in Microsoft using the system. When I say using, I don't mean looking at portals. I mean active developers writing in our query language. That's a huge number. And so we have to make sure that we build a system that could scale in terms of compute and storage, but also it can scale in terms of developers. It has to be very easy to learn and to use. And the workloads have to grow from simple operational analytics and sort of data mining into, again, machine learning, experimentation, voice recognition algorithms, a very wide range of things in the system. So that, this is what we've done internally. We had so much success with it. We wanted to bring it actually to the public as part of the data lake. So the data lake is not one thing. You can't go to Azure and purchase, quote, the data lake. There are actually 3 separate services, now one of which the audience may already be familiar with, which is HD Insight, which the simple way to think about HD Insight is you ask for you go to Azure, you ask for a cluster, and you get a cluster, and we call that clusters as a service, is a shortcut way of thinking about it. But what we've taken is, we've taken our internal system, and we've built a system based on it. Now, do they share some code? Yes. Are they literally the same code? No, they're different. They're different sets of features. And one reason for that is we have to build more when we build a public service that for customers than we have to build internally. Extra needs around compliance, security, isolation, etc. So we're taking the best of what we learn and offering us 2 new services. The first one is Azure Data Lake Analytics, and the second was Azure Data Lake Store. They're currently both in public preview. You go to the Azure portal and sign up for them. And then later this year we hope to make them available for general availability. So where HD Insight is a clusters as a service, analytics is a little different. It's queries as a service. There are no clusters involved whatsoever. And the scale is very dynamic, and it's a pay-as-you-go service and a scale-as-you-go service. Now the store part is what we call a hyperscale store, and all that means is basically we can work with many petabytes of information. And most important thing there, it's optimized to work with the data lake analytics. It's not a store you'd use just for storing big files, even though it could totally work. You're paying more for performance, and hopefully my demos will show you what that means. Now, these 3 services that I've highlighted in this slide in green are part of the Cortana Intelligence Suite. So I don't want to spend too much time on this, just want to let you know that everything you see on the screen now we're meant to work very well with. Now the services are just in preview, so not everything connects quite yet. But even today, Azure Data Lake Store, for example, and Analytics work with Azure Data Factory, right? And Azure Data Catalog works with the store. And we're working on integrating with Event Hub and SQL Data Warehouse. So the integrations are coming, but it's all part of a unified Cortana Intelligence Suite. So most of what I'll talk about in this presentation will focus on the new services. I'll hit a little bit on HD Insight, but the things I want to really focus on was what were our design principles for the Azure Data Lake. One is any data, which basically means we will scale to any size of data, any format of data, whether it be structured, unstructured, relational, document-based data, image, any kind of data. Number two, and you know, this is Microsoft's strength, is that we really do get what enterprises want, and they have very, very specific needs around compliance and security and auditing, and out-of-the-box Data Lake is designed for that. Finally, as I mentioned before, developers, you know, we cannot release a new system without it being something that developers would find very approachable and easy to take up. Now, one of the key ways in which Azure Data Lake is different from our internal big data system is that we have really shifted our thinking and our code base to be very dependent on open source, right? So for example, the compute layer, which consists of Data Lake Analytics and HD Insight, you know, it's built on the open source Yarn layer. In fact, we have developers actively contributing to Yarn. And likewise, the store is built on, and we think of it as, an open source web HDFS store. This is very different from what we have inside Microsoft. The system is not so based on open source, but here it's critical. And the reason it's very critical is that for both compute and storage, we want to make sure that we can work with the existing ecosystem of analytics tools as well as storage-based tools. So for example, using Spark on Azure Data Lake Store. Now, I'm going to show a demo of this very shortly, but it's a very quick system to get started with. I'm going to show it to you. It takes about a minute to set up and get and start using the system. Now we're in preview, so people will, when you sign up in Azure, it'll be a 24-hour period before you're approved to create an account. I've already been pre-approved, obviously. So you can sign up today, and once you're approved, your sign-up's approved, you can just do these steps. Just log in, create an account. It takes about a minute, and remember, accounts are free. We pay by query. You don't pay by just having an account. And you can start doing some sample queries immediately. So before I get the demo, let's just do a very quick overview of the services. So again, HD Insight is all about managed clusters, right? Today we have Windows clusters. We recently introduced Linux clusters. And we see that the growth for this area is going to be more and more people have been asking for Linux, and we delivered it, and we see that. Linux adoption has just been through the roof for Azure HD Insight. We've updated Azure HD Insight to work with both with Azure Data Lake Store, and previously worked with Azure Storage. And you know, we are incorporating more ISV applications like Datamir into Azure HD Insight. And one thing I want to emphasize is that HD Insight and Azure Data Lake Analytics are flip sides of the same coin. I'll spend a little bit more time on that later, but one doesn't replace the other. We expect people will work together with them. So Data Lake Store, again, is basically a web HDFS store. And you know, there literally are no limits of scale. Some other big data stores have sort of artificial limits, like the maximum size of an account, the maximum size of a folder, or the maximum size of a file, or the number. We don't really have those kind of accounts. There's not, for example, a, quote, biggest file you can store in the Azure Data Lake Store. It'll store as big as you want. And again, I'm going to emphasize it's optimized for performance with Azure Data Lake Analytics. Now, analytics has a very similar sort of focus on no limits and the dynamic nature of this. The one things I'll point out here is that we introduced a new language called U-SQL. And you know, the key thing here is that the difference between HD Insight and Azure Data Lake Analytics is that you don't pay for a cluster, you just pay for a query. And most importantly, you'll scale per query. And that sounds rather mysterious right now, but I'll make it very concrete in my demo. And I'm going to show you a little bit of U-SQL. This is a language that sort of blends C# and SQL together. Now, the U does stand for unified, But I don't want you to think that it's a unification of all SQL languages like Postgres, etc. We talk about unification in terms of paradigms like declarative programming with imperative, structured with unstructured data, or unifying querying across multiple data sources in Azure. So that's the sense of unification, not that this is a superset of all languages. And the key thing I'll talk about with U-SQL here is that, our developers inside Microsoft have been using this is sort of like V2 of our internal language, which is called Scope. You may have heard of it. And developers find it a very productive system to work with big data, right? And based on their feedback, we've improved the language, and the tooling for it is just amazing. You'll see a demo of that. And we think people, when they're using Azure Data Lake, will really find this remarkably easy to use. So I'm going to skip over this simplified administration and management. We're, of course, integrated Azure portal. So I want to get to the demos since I started a little bit late. So let's do a quick demo. I'm just going to show you what it takes to begin. So I'm in the Azure portal, and I'm going to do a new dashboard. And let me just oops, there we go. I just want an empty screen here. And I'm going to create a new Azure Data Lake Analytics account and just show you how easy it is and how much time it takes. So I'll click New, and you can see these services in Azure are grouped. I'm going to go under Data plus Analytics, and you can see Azure Data Lake Analytics is in preview right there. I'll click. Let me close this. So the key thing to pay attention to as I do this demo is how little I type in, or what I type in. So first of all, I have to give it a name, and I'm going to call it Saveen Demo 18. And I'm going to keep it in the subscription, which I have previously created. So far I've only typed in one thing, Saveen Demo 18. And in Azure, everything's in a resource group, so I'm going to create a Saveen Demo 18 resource group. I just have to type it in. I could reuse one, but I find it just more convenient to do this since I can always know what the name is. So I've typed in 2 strings. So it says locations is the next question. We're already in East US 2, and by the time we GA, we will be available in all regions in Azure, and beyond that, wherever Azure is across the world. Now there's no pricing tier for me to select because it is, again, pay as you go. And the final question, so I've typed in 2 strings. Now I have to select a store. So I'm going to click there. Now I have a couple of options. I can pick an existing store. It's loading up the list from all my subscriptions. Or I can create a new one. So I'm going to create a new one. And a little bit of a rendering error there, so let me just try that again. All right, not sure why it's not showing. We'll go one more time. Sometimes I'm actually showing a very early build of the portal we're using, not the one the public normally sees. There should be very few differences, but sometimes this actually does occur. Give it one more chance. Okay, it looks like it's having a little bit of a problem. So I'll go ahead and just select an existing one, which is like this one, ADL demo. And the key thing is, I know you didn't see it, but when I created the store, I would not have been asked for anything other than a name. In fact, the name would have been populated as Saveen Demo 18 ADLS. And then I'd hit 2 buttons, and then in about a minute, you'd get both accounts created, and they're linked. Now, I've already done this. So that's it. I basically had to type in 2 strings. That's it. So I've already created several accounts. So let's go and just view them. And we'll take a look. I've already created this dashboard. So we'll go to a previously created dashboard. And give me 1 second. I'm trying to get rid of this little thing on the right so I can have more screen real estate. There we go. Okay, so I have 2 analytics accounts, and they're both associated with 2 store accounts. I'm going to take a look at this one. So this is an account we actually use ourselves to monitor our own service, right? And you can see we have built-in monitoring. So I zoom out, you can see, for example, We have two graphs, which is the number of jobs submitted. Green means the job succeeded, purple means it failed. Yellow means it's canceled, and there's a dark blue there, which means it's running. And on the bottom, see the number of compute hours that I've spent in this job or in this service over the last few days. And so we have built-in monitoring. Now let's just take a look at some of the jobs there. These are jobs that are run all the time. It's been a decently used account. And we'll just take a look at this one. And you can just see this job has been running for a few minutes. It completed. And there's not much I want to focus on here. There's an interesting picture on the right, which I'm going to show you a much more interesting demo of in just a minute. But the other thing to notice here is just take a look at, when I created it, I didn't ask how to secure it because it's already built in, connected with our Azure Active Directory. So for example, as soon as this blade loads, you can see I have normal Azure Active Directory users and security groups added as users. And I'm going to show you also, you just browse the files that are associated with the store. So this is our basic system, and I mentioned you could get started very fast, and that's because out of the box we ship with a bunch of sample jobs. We have 5 right now, but we'll have close to 30 by the time we have our general availability. Here's a simple job that queries a TSV file. Now the script looks a little bit like SQL. We'll get a little more into it later. But I want you to notice something. I could hit Submit Job, and there's a slider over here that says Parallelism. And that parallelism means essentially how many nodes I want to allocate just for that job, right? And by default, the number is limited to, I believe, 20. Now, my account is special. I've asked them to increase my limit to 50. I've actually had it as high as 1,000. So basically, in this case, if I dial it up to 50, 50 nodes will be reserved for the execution of this query. As soon as the queries run, the 50 nodes go away, right? So again, it's not a cluster. You specify how many nodes you want for each query. So you can scale by query. And this is significant because it's the first way you can really control your costs. So before I do the next demo, let's go and now that I've shown you how to get started, some points I want to make about the services is that Azure Data Lake Analytics lets you query across multiple data sources. Notice not all the arrows have arrows in both directions. We do not write back to Azure SQL DB or DW, but we can read and write from Azure Storage as well as Azure Data Lake Store. Now U-SQL, I mentioned, was our language that integrated C# with SQL. It's a very easy language to get into. And here's just a table of the kind of queries you can do across different data sources. But let's take a look at the script a little bit. So some interesting features of this that sort of differentiate it from SQL. Notice we have this at orders. That's called a row set. Now it's not a materialized view or a common, it's in some sense like a common table expression in SQL, but it's a much more simple way of thinking about it. Basically it means that those represent all the rows flowing through the system. You can see I'm reading from a file called orders.txt, and because it is just a random text file, I have to explain to the system what the schema is, and that's what happens after this extract keyword. Extract means read from a text file. So I tell it there are 4 columns. I give it the types, and I give it the names. And then I'm saying parse the text file using extractors.tsv, which means I know it's a TSV file. We have other extractors like CSV, and you can build your own. And then I'm writing out orders into another file. That's a very simple, trivial example, but I just want to show you sort of how the language looked. It's not very complicated. Even if you didn't know the language, you'd probably understand, roughly speaking, what was going on here. Here's where it starts getting interesting. Now notice the select clause, just as we have in SQL. It says select customer.toUpper. This may seem a little unusual to you if you're used to SQL. And this shows actually the integration between C# and U-SQL. Because customer is not just a SQL, it's not a SQL string type, it's a .NET string type. And as a result, all the .NET methods you have on strings in the base common library are available, like toUpper in the select clause, or as you can see, the contains in the where clause, right? So this is one thing people find is very productive, because if you're already a .NET developer, then you know how to make all these transformations of data very easily, because you know them from C#. Now, what if you want to use a method that's not in the base common library, like it's not already a method of the string class or whatever? Well, the good news is it's pretty simple to use code you've built, whether it be in C#, VB, or F#. You just create a normal .NET assembly, you upload it to the store, and then you register it with the Azure Data Lake account, and then you just run this reference assembly, which means load that assembly, and then look, you can say orders db .helpers.normalize, and you've called a piece of C# code that you've written. Any piece, and again, this isn't written in C#, it's just any piece of .NET code. And this is another thing that really makes developers very happy with U-SQL, because they're not doing normal sort of things with these queries. Now, some people are using image processing or parsing JSON or reusing a library like Newtonsoft.json. And that's a little bit harder in SQL. It's much easier in U-SQL. Now, of course, we do have DDL to create tables. And besides providing schema for things and a known place where you can discover data, the other thing that tables do is actually enable higher performance. I won't go so much into that in this introduction, but it's a critical part of actually doing big data. Now, I'll skip this because I'm going to show a demo of it in just a second. So I showed you the language a little bit. Let's just show you now how the language works with our tooling. So I'm going to bring up Visual Studio 2015. Notice it's Community Edition, and that means that you don't have to pay for any of this. And I've already installed our Data Lake tools for Visual Studio. And how you'll get there is you go to View, Server Explorer, and this will bring up Azure as part of the Server Explorer. And I'll expand Azure, and you can see Data Lake Analytics is there. Now, it's going to list all the accounts I have in Data Lake Analytics and in all the subscriptions. So there's a massive list. So it takes it takes about 10 or 20 seconds to actually pull the full list. And so I'm just waiting. There should be, I think I have like 100 of these. There we go. So here's the full list. So I'm going to go to that same account I showed you before, Data Insights Ad Hoc, if I can find it right here. And I'll expand it to show you what's in it. I can look at the databases. I can look at the jobs. And I'll look at the storage. So we'll open up jobs. Now it's fetching the last, I think, 500 jobs that have been executed. And there's a bunch of them. Now what I'm going to do is I'm going to find a job very quickly that took some time to run. And I'm going to just click on Runtime. So I want a job that's kind of big. That's why I'm doing this. So I'm going to click on this to sort it. And one more time to sort. Okay, so we have one job that ran for 2 hours and 17 minutes. Let's take a look at that job. Now again, this is all built in. Open a new window. Okay, so what we're loading up is the details of the job. This is a very simple job. I want to show that. Let me just find another one. I want to show you something interesting with the graph. Though probably I'm sure it's not clear why I want this. This was 57 minutes. Let's see if this is a little bit more interesting for us to look at. I'm just looking for a nice graph. Oh, there we go. That's a very, very complex graph. A little bit more complex than I normally do, but it's still good to look at this. There we go. Open this new window. So the job took 57 minutes of runtime. You can see it succeeded. And let's just take a look at the job. Now, forget the thing on the right. The key thing I want to focus on is how much data. It wasn't a big job. Okay. It read about 280 gigabytes and wrote about 156. Not a very big job from our perspective. I've got 2 more numbers to talk about here, but before we talk about them, let's look into the script. So this is, again, just a normal U-SQL script. This is a much more bigger script than what I showed you before. But you should see, again, this is basically SQL, and you can see drop assembly, create assembly. This is, we're using Newtonsoft, CSV helper, again, how you can reuse .NET code. And often when you're debugging your own job or someone else, you want to see how the script sort of flows data and statements. So we have this design view. So I'm going to zoom out, and this is a very complex script as it turns out. So the design view is kind of big. And if it was a little simpler though, let's say I want to know where there's performance issues, I could find where there's a join condition, and you can see, I know this is kind of zoomed in a bit too enough. So if I know where I'm doing joins, for example, I'll click on the join condition, and then here you can see the join and what the predicate was. And you can see the statements. Select, I was joining on another select. And then what if I want to see the schemas? I'll click this. And now the schemas are actually shown, right? So tools like this really help people debug jobs that they themselves haven't written, or help you understand data flow through a script. So this is a static analysis tool that's built into the product. Now let's get to the exciting part, and to set it up I have to explain that that script, there's something that isn't in the script, which is the number of nodes and clusters. Basically our philosophy is this: you write the script as if you're on one machine, you let us parallelize it for you. So to understand how this parallelization works, you see this parallelism number 20, and you remember previously I demoed a slider. So in this case, whoever submitted this job dialed the number up to 20. Now to understand that number, you need to understand this other number, which is vertices. So the script, the compiler and optimizer look at the script and looks at the operations it's doing on all the data that it's supposed to be running against, how the data is partitioned and clustered, and it uses heuristics and optimization techniques. And basically this number, 3,834, means that the system can chop up a job to 3,834 pieces of work. And then what I'm saying here when I drove the slider up to 20 is, if possible, try to do 20 at a time, okay? And some interesting questions. Let's suppose I could have dialed the slider to 1,000, I'd be paying a lot more, obviously. Would it be worth it or not? So there's something to keep in mind, and we'll get to that in a minute. So, if you were to be given this job, one of your first questions would be like, where are its bottlenecks? Where are its hotspots? Now we've taken all our developer diagnostics and baked it into the product, which is very interesting for a big data product. You don't normally get this level of detail. And it starts with this green playback button on job playback. I'm going to press it, and remember this job took about 57 minutes. Let's just see. This will take about 30 seconds. So I click, it's asking me a question. It says job profiles required. Okay, I'll click OK. It's going to load something. You can see somewhere up here it'll start loading. But the long and short of the job profile is each one of those vertexes was recorded. And you can see it's almost fetched it all now. So the start time, the stop time, whether the vertex was retried, all that was saved when the job was run. And when I said low profile, it's being downloaded to this machine. And it enabled some interesting diagnostic features. And I think it may be done. So let's try the job playback. Okay, so I know it's very small right now because this is a massive job in terms of complexity. But you should see the job is actually executing. And you'll see it'll come in a few seconds. You can see the progress moving there, right? So each one of those each little tick of those is a set of vertexes that are being run. And so this is the overall job. Now, no matter how long the job takes, it'll take 30 seconds to show. This isn't a video, by the way. This is a visualization of the vertex data and when they stopped and when they started. And so this is a complex job, so it was hard for me to detect visually any specific issue just by doing the playback. Let's try looking at some heat map analysis, which again are baked into the product. Maybe we are concerned that this job is very I/O bound. How would we prove that? I can go to display instead of progress. I can show data red. And red doesn't mean bad. It just means that there's a lot of data relative to the rest of the nodes. So you can see the red is on top, which means, yeah, these nodes are reading a lot of data relative to the rest. So if I notice that they were stuck, meaning most of the 30 seconds was spent here, that would tell me the job is sort of I/O bound. It's really sensitive to the amount of input data. Let's see if there's a distribution of output data, which is interesting. The data written. It looks like most of the data writes are also happening in the same node, so probably those nodes are doing a lot of work. And we look at execution time. Yeah, that's true. They're doing quite a bit of work but you can see the other nodes are becoming more greenish yellow, so the work is distributed. Overall, I would say this job is I/O bound. Now, there more analysis. Now, I went back and let me go back and talk about this parallelism and vertexes. And the key thing I want to focus on is, could we do better? Could we spend more money and have a faster job, or spend less money and have a slower job, and would it be worth it? How would you ever make that decision? Well, the good news is now that the profile is loaded, we actually have this ability. So this is not a very exciting, I clicked on this Diagnostics tab, it's not a very exciting tab, but in fact this is really one of the best features of the product. We've taken the top 4 or 5 questions that developers internally in Microsoft, after looking at millions of jobs, what they do, and we baked it in here. And so I'll read you what these 4 things are, and some of them are, again, not obvious, but let me explain what they mean because they're quite interesting. The first one says warnings. What that really means is there aren't any U-SQL usage warnings. So the person who wrote the script didn't do anything odd with U-SQL, something that was, for example, going to be a deprecated feature or something that would produce incorrect results. So that's good. The second checkbox says it's about the vertex runtime. Now, when we see a vertex run really long, like many hours, that's usually assigned someone who's written some very strange piece of C# code. This script didn't have that problem. That's good. Now, at the bottom it says memory check, and that's a very similar problem. Sometimes you write a lot of C# code, you're using a lot of memory, you don't realize it. None of the vertexes have that problem, so that's good. It's the third one here, which is quite interesting. It's got the most generic name of all time. And it says there's 0 issues found. But let's take a look at what this really means. So I'm going to hide some of the things that aren't so interesting, like queuing and duplicate discard, which are more debug features. So what this says is, at the top line is a blue line, which is set at 20, and that's how much the person who submitted the script asked for. The red line is how many nodes were actually used. So already you can tell something quite interesting about the script, which is most of the time it isn't even using all the nodes that you're paying for, right? Which is quite interesting. Essentially, everything above the red is something that you're paying for reserved capacity, compute capacity, but it's not actually being used. So that's quite interesting. Now the question is, can we do better? Like, should we do it? What happens if we pay more or less? So what you're looking at here is a graph based on the actual execution characteristics of the job we ran. And this is not a simulation. This is sort of a best guess about what would happen to if you ran this job as fast as you could with more parallelism. So the way to read this is, we think that if you were to submit not with 20 but 252, this job would get run, would be complete in much faster time, like 900 with 1,000 seconds, which is much faster than the 57 minutes that we saw in real time. And again, this is not perfect. It could be wrong by 50% in either direction, but it's a useful tool to see how the system thinks about your job. Now, let's see. We paid 20. What would happen if I just paid, I don't know, 10? And by the way, actually, before I type in 10, at 200, you can see most of the time the job is wasting resources, right? Everything above the blue is waste. So let's suppose we don't care how fast the job is. We just want to save money. We'll type in a smaller number, like 10. Now look at it. Everything's hitting 10, obviously, because that's the maximum that can be used. And what this reveals to you is that the job is very well utilized. You're not wasting any money, but look at the runtime on the bottom right. It goes up to 6,370 seconds. So this is a kind of very interesting tooling we've built into our Azure Data Lake system in Azure Data Lake Analytics that lets developers understand the performance bottlenecks and hotspots of their big data jobs, as well as enable them to make cost versus performance trade-offs, right? This is something you just don't see in other big data products. We've been using, this thing has been around inside Microsoft for I think about 4 years now, 3 or 4 years. And this is one of the most exciting things we have to offer as part of Data Lake. Is focused on cost and efficiency and debugging, because this is extremely normally very hard in big data. So we have to make sure that all our developers are able to be able to do debugging and optimization without too much effort. So let me go back to the deck, and I'll spend a few more minutes and we'll just open it for questions. So we often get this question, how do you think about HD Insight versus Azure Data Lake Analytics? And again, HD Insight is about clusters as a service, whereas Azure Data Lake Analytics is about big data queries as a service. We expect people will use them together. The thing you get at HD Insight is much more control and customization because you have a cluster. You can install software on it. And you can use all the latest things in the Hadoop ecosystem, right? In HD Insight, you have Spark, Storm, HBase, etc. And you can use any language they support, right? Now, it's much harder to use, even though Hadoop is getting easier over time. It's still a challenging system that requires experts, especially as the size of your data grows. On analytics, we live in a world where there's a lot of much more convenience and efficiency, and it's easy to scale. You don't have to buy a cluster. You scale, per query again, right? And we've found that people find it very generally easy to get started with Azure Data Lake Analytics, right? And again, you'll mix and match them as you need. And it doesn't mean to say that all the benefits of Azure Data Lake Analytics will always stay there. For example, we have already improved the Visual Studio tooling of HD Insight to show job graphs. We'd like to show those job graph animations and heat maps there too. And we'd like to take in elements of open source and bring them back into Azure Data Lake Analytics. So over time, not only do we expect people to use them both together, we expect both of them to influence each other, and both of them will get better. So I'm going to skip some of these, but basically it's about Azure Data Lake Store, because I want to get to questions. I talked about HD Insight versus Azure Data Lake Analytics. What about Azure Data Lake Store versus blob storage? Well, the answer here is, there are different scenarios first, whereas blob storage is kind of general purpose storage. Azure Lake Store is more expensive and focused on analytics. The billing is the same model. Azure Lake Store is much more focused on being Web HDFS compatible. And what that means is you can use Web HDFS, tools that work with Web HDFS on Azure Data Lake Store. Whereas blob storage focuses on access keys, Azure Lake Store is already integrated with Azure Active Directory. Whereas blob storage would use access keys for authorization, and ADL Store, use POSIX style ACLs for files and folders. And finally, Azure Blob Storage currently supports server-side encryption, whereas Data Lake Store will soon support Blob Storage supports client-side encryption currently, and they're working on server-side. We already will support server-side encryption once we GA. So ADL Store is a much more enterprise-oriented store focused on analytics and working with big data open source workloads. So now that I've done the two demos and gone through the decks, we have about 10 or so minutes left. I thought we could take any questions.
Great presentation. Thank you very much.